Hey guys, in this video I have 5 examples for you and we'll be going through these examples to learn what is freezing in the first example, and the next 2 examples will be about working with characters, and the last 2 examples will be about working with booleans. Let's get started. I've created a new project using cargo new and I've removed everything in the main.rs file. Please do the same. I've shown how to do that in the first video itself of the series. And here we'll go ahead and create our func main. And here I'll create a mutable variable called mutable integer. And let's give it a value of 7. Now I32 is a way of post suffix, right? You can suffix it at the end. So I followed that here. And then I'll create a code block. Code block basically encapsulates some particular code which does not affect the code after the block usually. And you must have seen code blocks in Golang or JavaScript wherever you come from. And here, since this is a mutable variable, I can go ahead and copy and paste this and change the value to 3. And this should be fine. And if I print out the value out here, the value that now you remember, to be able to print this out, we'll have to use these 2 curly braces. I've shared that in the second video, I think, of the series. And then you're able to print out this value, okay? And this should work completely fine. But in this code block, I want to try and do something else. I want to try and do something which you have never seen before, okay? What I'll do is I'll take mutable integer and I will assign the same value. So I'll make mutable integer is equal to mutable integer. Now this is called as freezing. And if you pick up any Rust projects on GitHub and you go through the code, you'll see this being used by experienced Rust developers very often. So the perspective that I'm teaching Rust to you from is, if you were to go ahead and pick up projects and you wanted to learn how they work and understand and read the code, you shouldn't be confused. That's my main objective here, okay, apart from just learning Rust. So you'll see this freezing quite often. Now, how does it work? So if I now print the value of mutable integer, what do you think should happen? Should it work? Should it not work? And in relation to that, if I try to change the value of mutable integer, what happens? Because mutable integer, because this is the main place where people get confused, because you had mutable integer, which is mutable. Okay, the value is 7, and you assign mutable integer to mutable integer, and then you change the mutable integer value to 50. Now I'm trying to print mutable integer, and apart from this code block, I have some other code here, which for now, if you want, you can comment it out. And what we'll do now is we'll head over to our terminal and see how this code responds, but feel free to take a guess. So we can go here and we can say cargo run and see what happens. So println obviously is not a function because we had to put the exclamation mark there, and Rust tells you that. So that small issue I'll just quickly fix it and we'll try to run it again. Okay, I've fixed the issue and now we'll run it again. So now is the error which I wanted to show you. So it's saying cannot assign twice to a mutable variable, immutable integer. So why does it say immutable variable when we have actually mentioned that it's mutable, right? That's a problem. So it again says cannot assign twice to a mutable variable. Now let's head over back to our code and see, and let me just explain to you the whole thing again. Okay, so now hopefully you can look, view my code. Okay, so now I hope you can see my code now. All right, so here we were basically talking about freezing. So when I say that mutable integer is equal to mutable integer, it's basically freezing the value 7. Now, why would I do that? I do that because at some code blocks, I might want to freeze that value and keep that value immutable. And in some places, I might want to mutate that value. So if I uncomment this code now and I make mutable integer equal to 3, which it was 7 earlier, now it's 3, and I comment this out, because in this code block, in this specific code block, when I freeze mutable integer, I cannot change the value of mutable integer. But here I would be able to do that because I have not frozen the value outside this code block. So now what we'll do is we'll go again back to our PowerShell, and let's see what happens. So we'll go ahead and again run the code. We'll say cargo run, and now you can see there are no errors. So firstly, the value is, let me show it to you, is 7, and then you can see the value is 3. Okay, so inside the code block where we have tried to freeze the value, it's 7 because that's what we started with. And outside the code block where we are trying to mutate the mutable value, obviously the mutable variable, the value is 3. We try to change it because we have not frozen the value 7 there, right? So let me show you the code again, and let me explain to you again so that everything is clear. So what happened here was that we started with a mutable integer variable, which was mutable, took the value of 7, which is i32, 32-bit integer. And then if you ignore this code block, we just change that value because it's obviously mutable, so you can change the value easily. We changed it to 3, and when you printed it out, it showed us 3. And in this block, code block, now before I talk about this code block, remember that this variable, mutable integer, acts as if this code block does not exist. And that's what happened here, right? But inside this code block, right, you had mutable integer, and you had access to this mutable integer, but then you assigned it mutable integer again, and that froze the value. Now if you try changing it, you can't change it. And when you print out the value, you get the value of 7 because that's what it was to begin with, right? So now that's how you got in the terminal 7 and 3. Now this is a very interesting characteristics or interesting property of that you get in Rust. You will see this in multiple places. Like I said, with experienced developers, if you read their code, you'll see that they use these kind of code blocks. They freeze the value of a variable for a while, and then outside those code blocks, they're freely changing around those mutable variables. It's a little different to get used to first, but once you get used to it, the applications are many-fold applications, many places that you can use it. All right, now let's jump into our next example. So again, I'll start with an empty canvas, empty file. What we'll do here is we'll say function main, and we'll say let c1, which is character, equal to a. So c1 is a variable, it's equal to a, character a. And then I want to check the size of c1. Okay. Now to check the size of c1, I need to use a function called size of val. And this function does not exist by default in Rust. So you have to kind of import it from a package. Now, just like Golang, even in Golang, you can't even print stuff. You have to use the FMT package. And that's because Golang is very modular. But Rust has things like printing. You can print out stuff, but things like size of val, you have to use external packages. Now, the way, we'll obviously talk about it in more detail, but I just want to give you a glimpse of how you can import packages and functions from a package into a Rust file. So the way to do it is you say use, okay, and then you write the name of the module or the package you want to use. So in my case, it's standard module. And then I want to use mem and mem module, sorry. And then I want to use size of val. So mem module is a part of the standard library, and I want to use the function size of val. Okay. So now, so that you're not, you don't think this exists in vacuum. Let me show it to you in the browser what this library looks like. So here you can see the standard library, the Rust standard library, and then inside the standard Rust library you have mem module mem, Inside that, you have a function called size of val, which returns the size of the pointed to values in bytes. Okay, and this is the function we want to use. So now let's go back to our code editor. So this I want to show you because I wanted to show you this because you need to be able to understand and find out the functions that you want to use by going into libraries and going into the modules that you want to use. So C1 is A, going back to our code, and I want to check. So you know how you check two things, which is assert equal. We've used in our previous videos as well. So here's where I'll use size of val. And I want to see what it is equal to. So let's say, is it equal to 1? I'm not sure. Should be equal to 1, right? It's just one character A. So it should be equal to 1 byte. You can say because size of val returns the byte, value in byte. Okay. So size of value, and here you want to pass C1. Okay. And we'll print out success. Only thing is, you can't just send the value of C1. There's the concept of borrowing in Rust, and we'll be talking a lot about it in the future. Right now, you don't need to know much about it. Only thing is that there is something called passing by reference or borrowing, and some functions, they borrow variables like this through reference. So if you've worked with the C programming language, we worked with Golang, if you've worked with PHP, you probably know about reference, how you can send values by reference. You have a similar concept in Rust. Like I said, we haven't talked about it yet. All I'm focusing on right now is showing you what is the size of that character. To do that, I need the size of value function, which I got from this module. We will be talking about modules more in the future. We'll be talking about reference more in the future. We'll be talking about borrowing, the concept of borrowing more in the future. All I want you to understand right now is size of val returns the size of C1 in bytes. And we just want to know how many bytes is it. So what we'll do now is we'll go ahead and try to run it. So let me open up my terminal out here itself, because otherwise I have to keep jumping again to my PowerShell. So here I'll say cargo run. Let's see what happens. So it does give me an error. It says process didn't exit successfully. I hope you can see it. Okay, so you're not able to see it. Let me resize this so that you can see it. Okay, now you can see it, I think, hopefully. Or instead of just resizing from here, maybe I can extend the terminal here, and then also you'll be able to see it. Okay. So now you can see here, I get an error, process didn't exit successfully, because left the value is 4 and the right the value is 1. So here the value is 1, whereas this left the value is 4. So Rust is telling me exactly what the value should be. It's also saying assertion failed because left is equal to right. It didn't happen. It panicked, basically. And panicking here is the same concept that we've learned in Golang, which is, if there's a failure, the whole code panics or just stops executing and exits. So this means this should have been equal to 4, basically. So we'll say equal to 4, and you will now clear and run cargo run again. And now we have success. So C1 is equal to 4, in fact equal to 4. So what should we look at now? So what we can do now is we can have another variable C2. So C2 will be equal to a Chinese character. So let me copy and paste Chinese character from somewhere. Okay, it's a Chinese character. Now it could be a Korean or Japanese character. I'm not a Japanese, Korean, or Chinese guy, but I'm pretty sure it's a Chinese character. But if I have got it wrong, please forgive me. And here you'll have assert underscore equal to with exclamation mark, and you want to say size of val. Now what I want you to see here is this character is this a different size or is it also 4? We want to see that. So we want to see that if all characters in all languages are they of the same size. So let's see if it's 3 or whatever it is, and we'll say C2. Okay, so right now I'm assuming it's 3, but even if I run it, Rust will anyways tell us what the actual size is, just like it did in the last time. So here we're running it, and here it said right is 3 but left is 4. So again, the main critical learning that we got here is that doesn't matter which language or what character it is, it's always 4 bytes. That's great. And then we saw what is reference. We have not talked about it yet. We will be. And then we've seen how we can import values or functions from different modules, even though we'll be talking more about that. Okay, so here, this is what I want to show you. Now, we will do one more thing with characters, okay? One small thing. So what we'll do now is we will remove this code, and we'll say again, actually, let me go back. Let me remove everything and just copy this thing, the Chinese character, paste it here, and remove everything else. Okay. Now we will call a function called print char. Now, mind you, this is not a function that exists in Rust. This is a function that we'll create on our own. And let's print out the value of C1. And to be able to do that, we will have to define this function. So we'll say function print underscore character. And here we're accepting C as an argument. It's of type character, just like you do with Golang, right? You have, whenever you're accepting some arguments, you write if it's string or if it's, whatever number or whatever integer. So you write all of that there. And similarly, you're doing that out here in Rust as well. So you'll say print ln, and we'll print out the value of C. Now, we'll see something here which may or may not be very clear to you right now. I just want to show this example to you anyways, and in the future we'll be talking more about it, obviously, but I just wanted to show it to you anyways. Even if you don't understand it, it's completely all right, right? So character is what we are expecting. C, we're printing out the value, and we can get rid of this because we're not using size of val anymore. So now let's head over to our terminal. Okay, here I'll just clear this out, and here we'll say cargo run. As you can see, it was able to run, and you got the character. Now, the reason I said that I don't expect you to understand is because we are using functions, and we've not talked about functions yet. We're using arguments, not talk about arguments yet. So if you're not from a programming background, you'll probably have trouble understanding it. But if you're from a C programming language or JavaScript or Golang and background, you would understand that we called a function, okay, which is an external function, and that function basically accepted C1, which is the value of this character, and it was able to capture that in a variable called C. The name has changed from C1 to C. It's of type character, and we printed out the value of C, and it was able to print it out. Okay, so just wanted to show you how you can work with strings, but with different functions, and if you pass them around, you write like this, char. This is what I want to show you. Okay, now we'll work with Booleans. Sorry. So what we'll do now is we'll say fn main, and we'll say let underscore f, this is of type Boolean, and we'll make it false, and let t is equal to true. Sorry. And what I want to show you here is this negation character, right? Negation. If you have worked with this in JavaScript and Golang, feel free to skip this part. This is for people who don't know what negation is and how it works. And here you'll say println success. So here essentially what's happening is that we have defined a variable called f_f, which is false. We've also defined t, which is true. We've said here if t is not true, so whenever you say exclamation mark, whatever the value of t is, it just becomes the opposite. So here if t is not true, which means if t is false, then you print out success. But we know that t is not false, so it's not going to print out anything. So we'll say cargo run. Sorry, there's problem with the spelling. Okay, so nothing happens, right? Nothing happens because this complete code didn't end up getting executed. But if we said if t, just like that, just t, then will we be able to see this part, success? Yes, then we can see success, right? And if we said not underscore f, that means if the negation of f, so f is false, underscore f is false, if the negation of f is true, then you run this, otherwise don't do anything at all. And negation of f is true actually, because f is false, underscore f is false, so negation of underscore f is actually true. So we should be able to see success. So let's run it. Yeah, so we did get a warning saying unused variable t, but everything else looks all right. We did get success. Okay. And now to our final example for today, where I want to show you the AND operator. So we'll be talking about operators in the future, logical operators, but I just want to give you a quick rundown on how it works. So let's say, again, if you're from a JavaScript and Golang background, feel free to skip this. Like if you have a programming background already, you don't need to watch this because this is, again, for complete beginners. So we'll take a value called f, should be equal to true. Take the value of t, which we'll say is true, and false. Okay. So this and is a logical operator. It just says that the and of true and false. So the and of true and false is always false, by the way. And we'll assert underscore equal to exclamation mark. We'll talk about logical operators more in detail, but I'm just giving you like a quick overview of what it looks like. And now we're trying to assert the value of t with f. So we know that value of f is true. The value of t, which is true and false, should be false because the and of true and false, and operation of true and false is always false. So t should be false. So if we try to equate t and f, we shouldn't see anything. The assertion should fail. But let's see, let's run it and see what happens. So we'll clear this, and I'll make this a little larger, and I'll say cargo run. Okay, so it says assertion failed. It says left is false, right is true. And what if we made it false? You save it, you clear this, and you run it. So now you get success. So because f is false and t is also false, that's completely okay. Now apart from and, you also have OR operation, which we'll look at later on when we talk about operations. But here I just want to show you how you can work with Booleans, and you would see this code very often, people using AND operation. And there are more operations, like I said, we'll look at them later on. And those AND operations and OR operations, not necessarily we have to use it only with Boolean, we can use it with many more things. Okay. All right, so this is it from my side for today. So we looked at 5 examples. We looked at freezing, we looked at characters, how to work with characters, and we looked at how to work with Booleans a little bit more, right? So you have more clarity now. You do more examples, you get more, you see all these small concepts from different angles and different perspectives and in different light. That's how your experience grows as a developer, right? So whatever I've done, do all those examples with me. Maybe watch the video again if you have to. and then you'll feel a little more confident with Rust. And these basic building blocks on the fundamentals is what you want to focus on in the beginning. The beginning 1 month, even if the whole month just goes into fundamentals, it's completely all right, because the clearer your fundamentals are, the easier and less challenging it'll be for you to build bigger projects. All right, so I'll sign off here, and we will look at more interesting things in the next video. So do subscribe if you haven't already. Feel free to share it with your friends, because this is awesome content, right? Why wouldn't you? And I'll see you in the next video. Thank you.